For the now you try problem, again, take some time to read the question first and try to do at least some of the parts to your best ability before you continue the video. And for this particular situation, I would actually recommend you drawing a picture before you try to figure out the specific answers. It's going to be really helpful to be able to label a graph and visualize the scenario that's being described first. So if you have tried this problem, I assume you have a graph that looks somewhat similar to what I have done over here. So I create a graph and we know gutter is 10 feet above the ground, and we have the middle of the roof over here, which would be essentially the top of the roof in the middle. That's what we're assuming. And the first question we're asking is, if you move 2 feet from the gutter, how high is the roof over here? So essentially we're saying if you were somewhere at this point, what is the height of this roof over here? And when you calculate the height of the roof, don't forget that the gutter is 10 feet above the ground already, so that'll need to be taken into consideration eventually. But if we just think about how high this point is, we can first think about how long this little side is going to be. So essentially how high above the gutter that point of the roof is in this case. So we know we're moving 2 feet from the gutter. There are multiple approaches you can read into the slope being 412 over here. One way we can think about it is for every 12 inches over you go, the roof goes up by 4 inches. So right away you can see if we have 2 feet, that means we're going 24 inches. That's one way we can think about it, because 12 inches is equal to 1 feet. You can alternatively do the other way by converting 12 inches into 1 foot over here. But either way, you probably will be able to recognize the idea that we're talking about doubling the distance we go over based on our definition over here. So when we write out the calculation, we could do, if we have 2 feet, because it's 24 inches, we can multiply the 24 inches by the 4 over 12 being the slope over here in this case. And when we calculate this, we are going to get the result through the cancellation. We should get 8 inches over here. So be careful with the different units going on in this scenario. We should get 8 inches. If you use feet, you get 2/3 of a foot over here. Both answers will be correct depending on which units you used consistently over here. Now if we want to think about how high the roof is altogether, we need to count the 10 feet that's above the ground over here. So in this scenario, we would say that the roof at this point is 10 2/3 feet above ground over here. Now similarly, if we have the situation where we want to find how high the roof is at the middle over here, so we're looking at this particular point over here as to how high it is. And to find that, we are essentially using a similar process to think about how long this highlighted side is going to be first. And to find the highlighted side, we know that that's 15 feet over from where the gutter is. So we can do the same thing and do the 15 feet over here. And this is where I would suggest using feet instead of inches, just so you can work with smaller numbers over here. And to interpret this, we can say with a slope being 4 over 12, that means every foot over we go, the roof goes up by 4 inches over here, or a third of a foot over here. So let's say if we want to work with how high the roof is at the middle, we would be working with this side, with the distance being 15 feet over, and then we can think about the 12 inches equal to 1 foot, and 4 inches really being equivalent to 1/3 of a foot over here. But either way, you should get the result of multiplying this quantity by 4 over 12. And this is where I like to carry the units so I know what unit I should be using at the very end. And notice the slope is unitless because that means we're always using the same units, whether they're both inches or both feet, on both the numerator and denominator in this process over here. So even though I change the input to be with respect to feet, I don't need to change the slope because the slope is a ratio that's consistent. It doesn't have a unit to restrict that. So with this, if we calculate it, we can do a cancellation of 1 over 3, and then 15 times 1/3 gives us 5 feet over here. And with the gutter being 10 feet above the ground, we can say the roof, the middle of the roof is 15 feet above ground. Now, in these scenarios, we're just multiplying things out to evaluate and find out the result. Essentially, that means we're given the input and we're trying to find the output. For part C and D, part C, we're going to look at a scenario where we're given the output and trying to find the input. So we want to find how many feet in from the gutter must you go to find a roof height of 11 feet. So if the roof height is 11 feet, that translates directly to 1 foot above the gutter over here. And that means when we're looking for that particular distance over here, let's call it x, for whatever that distance we need to go, we always multiply this by 4 over 12, which was the slope we had. You could reduce this to 1/3 by now if you recognize that they are equivalent in this process. And this should be equal to 1 foot over here. And to calculate it, we really get 1/3 x is equal to 1, so we can multiply 3 on both sides. And therefore, we will get x is equal to 3, and in this case, because we're talking about feet in the calculation, because this is feet, this x will be equal to 3 feet over here, and that's what the question is asking. So we would say we need to go 3 feet over from the gutter. In order to find the roof height of 11 feet over here. And now if we want to think about what are the inputs and outputs over here, again, we're thinking about the inputs being whatever we plug in that we can just calculate or evaluate in order to find the answers. So when we look at what we did with parts A and B, what we did was we multiplied the number by 4 over 12. That particular number is this horizontal distance that we need to go from the gutter to any part of the roof over here. So the input is a horizontal distance here. Just to make that more clear over here. And then for the output, it's going to be the height. Technically, the height needs to consider the 10 feet as part of the final answer, but for what we are considering, the height or the vertical distance is the output for the function. Technically, it's a vertical distance above the gutter over here. And in this case, if we want to think about it over here, you might be able to define the height differently in our scenario, because here in part C, you notice that I subtracted 10 feet right away. So if you consider that 10 feet as part of your function, you could technically build the height to be just the height from the ground. Then when you're setting up the equation, you'll need to add 10 to our setup in order for it to be equal to 11. So the alternative setup will be saying x times 4 over 12 plus the 10 feet is equal to 11. So that would give you an equivalent equation to what we did over here. But with what I did, we would see the vertical distance is above the gutter that we have. So for the horizontal distance, we can see it's anywhere from 0 to, because we're going to the middle of the roof, it keeps going higher, we can go all the way to 15 feet over. So we can say it's going to be 0 to 15 feet. And it could technically be inclusive. And now for the height that's above the gutter, we can start from 0 and go into the highest point being really 5 feet. That's what we calculate in part B. We found that's going to be 5 feet over here. So with this, we would get 0 to 5. Again, it's measured in feet for our purpose. And that's how we can answer the questions over here. Make sure everything makes sense to you, and make sure especially the inputs and outputs over here, they have restrictions on both ends based on what we're describing here.